Benar, Pak.
Ya, oke. Berarti selanjutnya yang History of AI. Ya kan? Selanjutnya History of AI. Ya. Dicoba aja, Mas, di play.
Let's dive into the history of artificial intelligence. See how we got to this exciting point in history that we're at today. So AI has gone through several cycles where there have been both significant amounts of investments and excitement, as well as large lulls in these investments, as well as the excitement. So going from earlier algorithms and the initial excitement, as the term artificial intelligence was officially coined, and the first investments and promise began to be discussed on a larger scale in the 1950s. We then, in the 1960s and 1970s,
Ini berarti sejarahnya AI ya.
as yield failed to live
Iya,
up
Pak.
to
AI winter itu apa?
the
Istilah
initial
apa? Ada yang tahu nggak AI
expectations.
winter?
Then, in the 1980s, AI
Ya,
got its second
istilahnya
boom
AI
as
winter.
physicists found it possible to utilize rule-based algorithms called
Baru pertama kali dengar saya, Pak, untuk istilah AI winter.
Ini kalau saya cari AI winter adalah periode waktu di mana minat dan pendanaan untuk penelitian AI menurun secara signifikan. Itu periode ya, setelah periode waktu. Antara tahun berapa? 60-an ya? Ya Mas, dilanjut aja coba.
expert systems to aid in decision making. Along with that, many theoretical breakthroughs introduced the promise behind
Ini berarti
neural
urutan
networks.
algoritmanya ya, ada
But then, as
system,
promised,
neural
we
network.
had another AI winter in the late 80s and into the 90s, another failure to be able to leverage the promise of the expert systems and neural networks in practical applications led to another decrease in investments. Then, in the late 90s and early 2000s, machine learning proved to be successful in many tasks, such as speech recognition, Google's search algorithm, and many others.
Ini subtitle
And then
perlu nggak, Mas?
finally, fast forwarding to today,
Kalau enggak ya
there were
nggak usah.
many breakthroughs in deep learning.
Tapi kalau mau pakai subtitle ya nggak apa-apa.
Subtitle.
Subtitle coba di ini loh Mas, di yang kanan bawah itu yang tanda apa namanya? Yang setting kanan bawah di videonya itu.
Proving to be able to
Coba, muncul nggak?
overcome many of the historical
Tekan
practical
bahasa
limitations of the initial
ini.
neural networks, and
Ya,
they
kalau
began
mau
to
pakai subtitle, kalau
outperform
enggak ya
classical
nggak
machine
apa-apa.
learning techniques in many complex big data problems such as image classification and machine translation. So we see this up and down, and then finally here, this excitement around deep learning as able to accomplish all of these tasks that were once set with such high bar when we first started to think about artificial intelligence. So let's go all the way back to the beginning. In 1950, Alan Turing developed the Turing tests to test a machine's ability to exhibit intelligent behavior. Alan Turing's test has served as a foundational threshold for artificial intelligence. The idea being, will a computer ever be able to sufficiently imitate a human to the point where a suspicious judge cannot tell the difference between human and machine? So then in 1956, artificial intelligence was accepted as a field at the Dartmouth Conference. This Dartmouth Conference was where the term artificial intelligence was actually first coined. With this conference, researchers from various fields excitedly agreed that artificial intelligence, that is the simulation of intelligent behavior in computers, was indeed achievable. In 1957, Frank Rosenblatt invented the perceptron algorithm, which is the precursor to our modern neural networks. And it generated a ton of excitement in the field, as it showed how one can come up with a model that actually learned from data fed into the machine. And then in 1959, Arthur Samuel published an algorithm for a checkers program, which was intelligently built according to the limitations of computation at the time, obviously, to learn from the current state of the board and the positions it had seen in the past to come up with the next move. And Arthur Samuel is well regarded for popularizing the term machine learning. So we see here in the 50s the advent of these key terms that we've discussed, artificial intelligence and machine learning, as well as the precursor to deep learning in Frank Rosenblatt's perceptron algorithm. As promised, following this excitement, we face our first AI winter. During the Cold War, machine translation, specifically between Russian and English, was one of the major goals in artificial intelligence. In 1966, a committee was formed of 7 scientists, put in place by the US government, specifically to assess the progress of machine translation, and this group deemed there was very little return on investment, dealing a major blow to the hype around artificial intelligence. Then in 1969, Marvin Minsky's work identified major limitations to Rosenblatt's perceptron algorithm, dealing yet another blow to artificial intelligence. And then in 1973, the highly regarded British applied mathematician James Lighthill published a report highlighting how discoveries and research had fallen well short of the high hopes laid out over the past few decades, leading to governments cutting back much of their funding in artificial intelligence research. These major public reports led to large cuts in government funding for AI research, leading to our first AI winter. Then, as discussed, we have our winter, then we have our next boom. In the 1980s, expert systems became all the rage. These systems were built with programmed rules designed to mimic human experts, the idea being to hard-code the machines with facts and rules representing expert knowledge of different subjects. These programs ran on powerful mainframe computers using specialized programming languages such as Lisp, which is one of the oldest high-level languages
Mas, coba di apa Mas?
and was the most popular for artificial intelligence research at its time. These expert systems gained huge popularity.
Digeser aja.
AI infiltrated
Tapi
the
nanti
business
kalau mau
world
di
at large
reply
scale for the
ulang
first
ya
time in
boleh.
the 1980s. And then on another note, propagation
Sampai akhir.
algorithm, possible
Yeah.
that generate so much excitement, face many problems with implementation of problems with large data sets and large networks. And then with these in mind, the excitement behind utilizing artificial intelligence for business once again subsided. So we'll take a break here before our next video. And in our next video, we'll discuss the successes, as this is the last AI winter, that led to present day.
Sudah selesai?
Sudah, Pak.
Coba. Sebenarnya sudah tercentang hijau ya. Oke. Kemudian yang story Mas. Kita nanti sampai praktis kuis Mas. Yang story. Itu 5 menit. Ya. Kita nyalain aja ya.
So hopefully you are all on pins and needles, wondering what's going to happen next in the history of artificial intelligence. Now we're in the 90s and 2000s.
Yang lain sambil nyoba
AI
ya di
solutions
akun masing-masing
using
ya.
classical machine learning techniques began to take off, and AI solutions had successes in speech recognition, medical diagnosis, robotics, and many other areas. AI algorithms were integrated into larger systems, and once again became useful throughout industry. In 1996, Deep Blue accomplished the major feat of being the first machine to defeat a world champion chess player. So you can imagine the hype and excitement as a machine is able to beat a human in chess for the first time. Also, Google revolutionized the search engine space with its PageRank algorithm to display search results. And if you're curious, I would say look up that PageRank algorithm. It's a great start if you're interested in network algorithms. In 2006, the previous limitations of deep learning, namely exploding and vanishing gradients, which we'll touch on later in the course, were overcome with algorithmic advancements such as Geoffrey Hinton's work on unsupervised pre-training. Neural networks are rebranded as deep learning, as we are able to train much deeper networks with more layers. In 2009, the ImageNet database was introduced, which was a groundbreaking dataset that provided millions and millions of labeled images, which were not available before to data practitioners. And then in 2010, algorithms compete on several visual recognition tasks at the first ImageNet competition. And this greatly increased the opportunity for an algorithm to try and learn from many examples the complexities of the patterns that actually make up a cat or a dog or even a certain breed of dog. Now, I've heard that if we thought of the ups and downs of deep learning as a movie starting with Rosenblatt's basic perceptron, then the 2 long winters associated with Minsky's paper on the limitations of Rosenblatt's perceptron, the article introducing backpropagation, and then the corresponding response highlighting the problems of the vanishing and exploding gradients, 2012's competition would be the climax of this movie. As in 2012, a deep learning model using convolutional neural nets called AlexNet achieved a top 5 error of 15.3%, blowing out the competition. That was more than 10.8% points lower than the next lowest error. So from there, the practical applications for deep learning began to take off. In 2013, it was used to give description of the conceptual meaning of words by learning from copious amounts of written data. In 2014, we saw similar breakthroughs in the task of machine translation, leveraging concepts such as recurrent neural nets, making what was once one of the major goals in the 60s, if you recall, that was one of the causes of the first AI winters, an actual reality. And these have led to advancements in web search, document summarization, and machine translation. In 2014, Stanford researchers elevated computer vision to another level with the ability to annotate photos with captions, such as baseball player throwing a ball in game, rather than just saying this is a human, was able to give a bit of a story behind an actual picture. In 2015, one of the most popular libraries, TensorFlow, was built for deep learning, making it more powerful and accessible. In 2019, this was made even more accessible, while gaining even more flexibility and power as well, with version 2.0 incorporating the high-level libraries Keras, which we'll touch on later on. In 2016, DeepMind's AlphaGo was able to defeat a Go master, a game considered much more difficult than chess due to the prohibitively large number of possibilities for every single move. In 2018, Waymo, the self-driving car taxi service launched by Google, began actually giving rides in the suburbs of Phoenix. And in 2019, the IBM Project Debater put on a fascinating debate with a champion human debater, showing the ability to argue a topic, listen to a human response, and then give a rebuttal accordingly. It was fascinating to watch and would highly recommend looking into it. You can just look up IBM Project Debater on YouTube. And those are just some of the many major highlights of where we are today with artificial intelligence. In the next section, we'll dive deeper into understanding more of what makes this era in artificial intelligence so special.
Selesai. Coba next mas. Yang quiz berarti. Nah, ini. Start. Nah, ini kan soalnya sama nih mas. Soalnya sama ya buat teman-teman semuanya. Dia nggak random soalnya. Dia bukan random. Coba jawab. Next. Terus apa? Ini apa? Jawab aja. Terus coba. Ini submit. Input nama sih. Nama. Oke. 66. Nah, diulangi Mas. Ini kan 66% Mas. Ya. Berarti ada yang keliru. Yang mana yang keliru?
Yang machine learning.
Yang ketiga ya. Nah, yang ketiga ini, ya toh. Nah, kalau pilihannya dua gini kan gampang, yang berarti yang benar kan yang satunya kan. Tapi kalau nanti pilihannya itu banyak ya bisa buka video lagi. Coba yang nomor 3 Mas. Yang nomor 3 itu di retry aja Mas. Di retry berarti yang nomor 3 yang keliru ya. Di retry. Nah, ini true. Ya, true. Terus ini false ya. False. Ya, cek. Ya. Oke. Nah, ini 100%. Nah, nanti diusahakan nilai grade-nya ya di atas 80 ya, teman-teman semuanya ya. Ya, nanti nilai dari Coursera itu nanti dibuat untuk nilai UTS dan UAS. Ya. Next Mas, next item. Next item berarti ya itu materi selanjutnya. Ya. Materi selanjutnya.
Now let's dive into the AI landscape of today and get a better understanding as to where we are and why this era is different. So where are we today? Two spaces where we're seeing drastic growth and innovation.
Berarti Mas Irfan udah bisa ya nanti ya lanjutin sendiri ya?
Oh, sudah bisa Pak.
Ya, oke. Sudah bisa ditutup tampilannya. Ya, mungkin yang lain ada ini enggak, kendala enggak? Dicoba ya, Mbak Elizabeth, ya. Kemudian Mas Oki udah ya, udah nyoba ya. Mas Oki udah nyoba belum? Mas Oki sudah nyoba ya, cuma 22,5%. Berarti ini seperlimanya ya, seperlima modul EDA-nya ya. Nah, targetnya minimal itu 3 course saja, EDA, kemudian klasifikasi sama regresi, ya kan. Cuma kalau mau diselesaikan sampai akhir itu boleh, ya sampai unsupervised, ya itu boleh. Dan mau menyelesaikan course-course yang lainnya juga boleh, ya nggak apa-apa. Cuma untuk mata kuliah data mining kita sampai 3 saja tadi ya, 3 course. EDA, kemudian klasifikasi dan regresi, minimal itu. Ya. Minggu depan kita evaluasi lagi, nanti saya buatkan tabel prosentase capaiannya ya. Nanti masing-masing mahasiswa itu kita evaluasi capaian prosentasenya itu sampai berapa persen. Ya. Sementara ini yang 100% itu masih di Mbak Johanna, ya. Kemudian Mbak Cinta itu 97%, Mas Adif ya 97%, ya. Sisanya di bawah 90%. Nah, nanti kita evaluasi minggu depan. Ya, nanti saya buatkan tabelnya, tabel capaian prosentasenya. Ya, ini kan berarti kita masih seminggu pertama ya. Kita masih seminggu pertama. Kurang lebih nanti itu sampai mungkin seminggu setelah UTS ya. Mungkin total untuk Coursera ya. Ini mungkin 7 mingguan lah, kurang lebih ya, kurang lebih. Ini kan kita masih seminggu pertama ya. Untuk 3 course saja kalau 7 mingguan harusnya bisa ya. Berarti kan misalkan untuk kita buat target aja misalkan ya, sampai akhir Oktober itu EDA harusnya selesai, ditambah mungkin kalau mau regresi atau klasifikasi boleh ya, paling enggak 1,5 modul lah ya, 1,5 modul EDA ditambah mungkin klasifikasi atau regresi ya. Oke gitu ya, jadi minggu depan kita evaluasi capaian presentasinya. Mungkin ada yang ditanyakan?
Pak, absennya bagaimana, Pak?
Absennya udah tuh di sistem sudah belum?
Oh, sudah, Pak. Terima kasih, Pak.
Udah ya. Ya, sama-sama. Nanti kalaupun ada soal yang susah, silakan mungkin di screenshot ya, mungkin di grup ya, bisa atau tanya temennya. Nanti yang sudah bisa menjawab nanti bisa bantu jawab juga. Ya. Nanti boleh bisa saling bantu menjawab gitu. Misalkan ada soal yang kira-kira mungkin susah ya, itu bisa dikirim ke grup atau ke temennya ya, atau mau dikerjakan bareng-bareng dengan teman-temannya juga boleh ya. Yang penting teman-teman bisa menyelesaikan targetnya nanti. Itu ada pertanyaan nggak kira-kira? Nggak ada pertanyaan? Kalau nggak tanya Mbak Juana nih, grade-nya 100%. Ya. Gitu ya Mbak Juana ya. Gitu ya, nanti ketemu lagi minggu depan ya. Cukup ya?
Cukup Pak.
Cukup ya. Oke, nanti dilanjut sendiri ya. Ya, kalau sudah saya tutup. Terima kasih, selamat siang.
Ya,